All right, so this session is being recorded. Hello, everyone. My name is Prakash, and as Kumar mentioned, I work for Amazon as a senior engineer, and I've been programming for over 12 years now. So, kind of, it has been a while. All right, I welcome you all to the AP Computer Science course. Without spending a lot of time in introductions, probably we'll get introduced as we go further in the coursework. I just want to know how many of you have a prior programming experience. Maybe just write in the chat window. Okay. And okay, how about how many of you have some experience in Java? I don't know. Okay. Okay, cool. Who's Captain ZS?
Captain Zeus. Sam
All
goes.
right.
Okay.
So I think we have mix of everyone. Mostly all of you have some experience with Java. That's good. So, all right. So this will help me set up, at what level we should start with, and kind of include everyone in it. All right. So, being said that, I'll start to today's session, and you'll be seeing my screen shortly. There you go. All right. I hope you all can see it. If you cannot see 1.1 why programming, why Java, uh, let me know. All right. So again, welcome everyone. This is AP Computer Science. We'll be covering topic 1.1, which is why programming, why Java. So today's topics, we'll learn about why learning programming in 5 simple ways, why learn Java in 10 simple ways, what is Java, and we'll learn a hello world program. Very simple. We'll keep it simple. We'll keep it to the point. And if you have any questions, either you can just write it in the chat window, and I'll take pause during our session and go over the questions and answer them. All right. So we'll start with why learn programming. You know, it's first thing we should answer is why learn programming, because we'll see that in 5 reasons why we should do that, and we'll start with the most important to least one. So point number one, computer is everywhere. So as computer is everywhere, it influences the way we live our lifestyle. A computer is in our car, in our refrigerator, in homes. There's Alexa, Siri, phone, and there's computer everywhere in healthcare, sports. So we are surrounded by computers. Now, most often than we think of, these computers and devices, they control or define the way we interact with them or the way we live our life around them. So it is very valuable to learn programming so that we can control these computers around us and make them work the way we want, and not vice versa. Not only that, it is a great value to understand how these things work, uh, and just not use it as a dumb device. So that's a very big motivation to learn programming. You should be able to control them, and who knows, maybe make them. Point number two, create anything. As we are surrounded by so many computing devices around us, in a lot of times we try to combine these devices to work together to solve certain challenges of life. Maybe use a Raspberry Pi and sprinkler system combined together to create an automated sprinkling system, which doesn't operate when it's going to rain. It becomes smarter. So it's very intuitive for humans to combine two solutions to make a even better solution. So programming these devices will allow us to create anything we possibly can. And imagination is a limit here. Point number three, brain development. So how does programming help brain development? Well, it is good for brain development is and enhanced problem solving. Now, few of the challenges in computer science are such that even the fastest computers in the world cannot solve them in a reasonable amount of time, but a smart program can. Such kind of programs, they run into algorithms, which is not part of our coursework, but as programmers, when we start working on certain problems, we realize there are better ways to solve few problems than already existing ones. So there's always constant need for optimization, which requires creative thinking, and enhanced problem solving. Logical reasoning is enhanced. How is it enhanced? Is because it's a very classic saying in computer industry is it's computer is a garbage in garbage out system, which means if you put garbage in it, it'll give you garbage. It's not as smart as we think it is. It is fast but not smart. So the smartness is added by the programmers who write code for it, and hence logical reasoning is required here. Uh, uh, and finally, but not the least, is innovation and invention. Uh, so as we interact with computers, we try to innovate. We try to simplify things through innovation, and in the process, we may invent. And invention is not only writing cooler and better programs. It may also be solving some real world challenges. Maybe, who knows, COVID-19 genetic impression processing. Someone is doing it in the computer, right? And someone is going to find a cure for it. So programming helps brain development. It's a very big motivation to learn programming. Point number four, personality development. How does it and what I mean by that is development in collaboration skills. And why is it important? Because if a programmer or if a human being in general is collaborative, uh, they can work with people of different walks in life and make this world a better living, better place to live and thrive. Now, how does computer programming help build that skill? Is because computer is everywhere, all around the world. Engineers, enthusiasts in different countries of the world, speaking different language, uh, with different cultural background, they all are doing one common thing, which is programming. And sorry, did I? Is there any question? I'll take it as no. So coming back to what I was saying is people from different parts of the world, different cultural backgrounds, different educational backgrounds, different skill sets. They all get connected through one common skill, which is programming. And when that happens, it is very often that one programmer has to interact with a programmer from a totally different background, and for a better interaction, all programmers have to learn some or the other part of the culture everyone comes from. So it gives an opportunity to develop a diverse network internationally. Who knows, you may be working with someone from Romania one day or from some other country. It improves collaboration skills. You'll know about cultures, you know about habits, and so many soft skills, and not only core technical skill, which helps in growth. And whatever skills you develop through programming are transferable. What I mean by that is, today we are planning to learn Java. Who knows? tomorrow you'll plan to learn some other language. A new language which is not existing today will come into picture someday. It will not mean that whatever we learn today will be lost. Is because at the end, uh, life moves towards simplicity. No one wants to make a more complex programming language than what already exists. So whatever we learn today, going forward, things will be just based upon it. It will become whatever you learn is not lost. It is reused in a slightly different way, but ideas remain the same. And having all these skills developed, it makes an engineer or a programmer self-sufficient. Uh, so that's very important to build some confidence. So when you write your code, you own it, and you take it to completion without being blocked by a lot of hindrances. So programming helps collaboration skill development. Point number 5, career growth. Now, this chart on the right side of the screen is job projection for next 10 years. And if you do the math here, you will realize almost 50% of jobs in next 10 years will require some kind of programming knowledge, some kind of uh, web development knowledge, or some kind of computer skill. It'll be computer skill will become a major requirement for all the jobs going forward. And we can see that trend catching up even today. You don't have to wait for 10 years for that to happen. So there is always there's going to be a strong demand in coders or for coders. There's as majority jobs require programming skills, it gives a lot of career flexibility. As an example, as a programmer, you can join a finance company and work for them. You may switch and join a healthcare company and work for them. All you need to know is to write good programs and some domain knowledge, which anyways you'll gain through experience. But the idea here is it gives so much of flexibility. Unlike, let's say, an electrician, if they want to decide to work on making a website, it's not a transferable skill. Or if they decide to become a plumber, it's not a transferable skill. It's a very specialized skill. Whereas programming is very flexible in terms of career. Skills apply to many verticals. By this, what I meant was you can work for a finance company, you can work for maybe for a healthcare, let's say Google, which is completely web, and so on and so forth. So there are a lot of verticals you can work in as a programmer. Build entrepreneurial skills. So as you work, new ideas will come because you'll be interacting with people. You'll be using a lot of your logical reasoning, and who knows, out of these things, you may come up with some bright idea that could be world changing. As an example, Google was one of such ideas. They started in a garage, and now it's one of the richest companies in the world. Same for Apple. So we have a ton of examples to show that. All right. So I think these 5 are strong enough of a reason for everyone to learn programming. Right. So moving on. But before I do that, any questions? Should I take it as no? Maybe I'll take it as no. All right. I hope I am audible to everyone. And I hope I'm going at a pace that's not too fast. Kumar?
Sure, good. I would recommend that that you point to the person and ask some recap questions.
Okay.
So just in case if Parashar is sleeping, then we can wake him up.
Hi guys, no sleeping at all. We may have some quiz, who knows, surprise quiz. Being said so, When I'm presenting my screen, then I don't see the chat. So Kumar, if you're keeping an eye on the chat,
Yeah, yeah,
then stop me and I can look at it and maybe we can answer some questions.
yeah, yeah.
All right, and everyone, if you have any question, you can just write in the chat or feel free, if no one looks at it, feel free to unmute yourself and pause me, and I'll be happy to answer that. All right, so moving on.
So
Um,
actually, let me ask. So Prakash used a term vertical. How many of you know the word vertical in the business world? Would it mean like versatile? No. Anybody else?
No.
Okay, so um, Prakash, you wanted to clarify that?
sure, definitely. So vertical, in by vertical, what I meant was um, those those set of industries which operate independent from others. As an example, healthcare industry um, has not necessarily do anything with energy production, energy industry, right? As an example, what I mean by that is hospital system may be working, often works independent than how electricity is being generated. So now these two types of jobs represent two verticals. So vertical would mean um, a collection of corporations who are independent from everyone else. They are of their own unique kind, and such unique kinds are called, vertical. This is what my simplistic meaning of vertical is.
Yeah, very good. And you guys can do some research. Again, as we are learning the fundamentals of Java programming, and as part of the curriculum of AP Computer Science A, you need to be able to articulate why learn programming and why learn Java. So that's the reason we are covering all of these topics. Again, type in your question. Don't be silent. Thank you.
All right. So moving on, why learn Java? Now, once we're convinced why learn programming, there are so many options in programming itself to learn. The question is natural: why learn Java? Why not learn Python, C, C++, or any other programming language? Well, somewhere one has to start learning something, and Java is a good starting point. We'll come to that, but before we get there, the inventor of C++, he said every programmer should know at least three programming languages and two scripting languages. So it's very common in the computer industry for one programmer to learn or to know more than one programming language and more than one scripting language. So the question is, which language to start with? Um, and Java is a great candidate to start learn programming, and we'll see this in 10 simple ways why we should learn Java. Point number 10, it's most popular. So Java is one of the most popular programming languages. This chart here on the left of the screen is from GitHub, which is an open source code repository. And for in month of April 2020, which is this month, Java is still at the top, followed by C, Python, C++, and so on and so forth. So it's very popular. On the right, the screen you see is a screenshot of installation of Java on a computer. You might have seen it as part of setting up your environment properly. Now, Java claims to be running on 3 billion devices. The world's population today is 7 point some billion, which means approximately between every two human on this earth, there's one Java program running. And like as an example, everyone has a phone. All Android phones are Java phones, right? Computers run Java, printers, websites. So Java is everywhere. It's very popular. So it makes sense to learn something which is very popular because you're going to run into some or the other thing which is going to be using uh, the most popular language to work. Point number 10, simple and open source. So Java is very simple because it is very close to natural English language, and it is also open source. So as it is close to our natural language, it is very simple and intuitive. So if you don't know things in Java, it is easy to guess, what it might be because it is like speaking English language. It is open source, which means the source code of Java is available for public use. You can download the source code and you can see how things are written within Java, which is a great source of learning. And not only that, when you write a program and if something is not working the way you want it, then you can look at the source code of it and figure out what is going on. Whereas a lot of programming languages are closed source, so you have to just use it. You can't go and change it. Uh, Java is platform independent, which means you write Java code once and it can run the same. The same code can be run on different platforms. It can run on phone, tablet, television, computer, internet. So you don't have to rewrite the same program again and again, which is such a powerful feature, in my opinion. And as it is platform independent, the reason why it is platform independent is because Java has this philosophy of write once, run anywhere. It's called WORA or WORA. It's write one time and then you just keep running the same program everywhere. Point number 8, rich API. API is application program interface. So why do we need APIs? Let's say you want to write a program to control your refrigerator. For that, you don't want to open every part of the refrigerator and hack into it. That's not programming really. It's hacking, right? You break into things and you hack it. So what these Java programs or any of these things that let you control them, they expose something called as application program interface, through which you can control them. You can control them in a precise manner. So Java has a rich set of APIs. In fact, within the Java framework, there are over 4,500 APIs, which means there are a ton of things that you don't have to rewrite. You can just use it out of the box through their API they expose. These APIs are backward compatible. What I mean by that is, let's say today we write a program to control our car as an example, and maybe car is the wrong example. Let's say we write a program to control our refrigerator, and then something changes, like an update happens, and that should not mean that we have to change our own program. It'll not be pleasant experience that every time you update a software, your program has to change. So backward compatible means you can keep updating, but even the older applications will continue to run the way they used to run. And Java has an excellent support for backward compatibility. So you write a program in Java today, and it will still work 10 years from now. All right. So moving on, point number 7, ton of resources and community support. So as it's one of the very popular languages, and Java is present everywhere, 3 billion devices, right? That's so many of them. There's a huge number of programmers who work on Java to fulfill these demands. and as so many people work in Java, they run into problems, and or they find some nice trick to solve some problem. These programmers, they collaborate. They collaborate through forums like Stack Overflow, or any of these kind of Reddit. Some write their blogs. People want to share their solution with everyone, make life easy for everyone. So Java has so much of support available on internet that any most of the problems that we'll run into, and I bet someone else has solved it, and we can find the solution on internet rather than reinvent the wheel ourselves. So it makes programming very easy because of that, because there's help available and plenty documentation. The Java, like Oracle Java as an example, has a nice Java doc available, which explains each API, parameters, behavior of each method. So it's very helpful. It makes our code predictable uh, because we know everything about it. So so having a lot of resources make life easy. Point number 6, Java applications. So Java applications are everywhere. Let it be web application, Android phone is almost all entirely Java. Big data, artificial intelligence, and a ton of frameworks. So you know, as an example, there are like millions and millions of websites that new websites that come up every day. Now it is humanly impossible to write a web server from scratch. uh, you know, it's just not feasible because those are so complex ones. So what people do is generally they write one web server and make it into a framework. As an example, in this diagram on the right of the screen, there's Apache Tomcat, which is a web server, WebSphere, Glassfish. So there are so many options to choose from. Uh, so now when you want to write your own web application, you don't need to write a web server. You can just use Apache Tomcat and give it the logic that you want to run. Um, Similarly, databases, web frameworks, and all of these. So there's Java has a huge set of options to choose from, which makes it very easy to write things in Java because you just pick things out of the box and start using it. Time to market is reduced. Point number 5, Java development tools. So Java has a lot of tools available online that you can download free of cost. These are called IDEs, integrated development environments, and these four are the top ones, the most popular ones used for writing Java code. Um, a good IDE makes it a good experience to write a program. And as Java has good support for IDEs, it makes it easy to write code and increases productivity. So at this point, I'll take a pause here, and any guesses? I would like to ask you all any guesses on what these IDEs are. Um, you can write it in the chat window. Kumar, can you read me a few of them?
Yeah. IntelliJ, Eclipse, and Android Studio. Edward says that. Zane also says that. Oh, I think they caught pretty much.
That's really good, impressive. You guys got it right. IntelliJ, Eclipse, that's NetBeans, right? So it's used. It's a very common tool in a professional environment. But
one is asking what's the first one, and somebody saying hot NetBeans.
yes, the first one is IntelliJ, And I think so. For this course, we are going to use IntelliJ. Um, and once we get familiarized with the coursework, we may not use IntelliJ for everything we write. It's because it makes writing Java so easy that it is habit forming. It'll be difficult for us to write program without IntelliJ if we get habituated to it. And during the AP exams, you have to literally write the program without an IDE. So as we get more comfortable with Java, we'll slowly shift to a non-IDE based development model. All right, but
Question here. I was going to ask the students, what is an IDE? What is an IDE? Anybody? Type it in. All right. Okay, Zane's correct. Integrated development environment.
yes.
You already knew it or you Googled it? That's awesome. Very good. Okay. Next question, API. What is an API and give an example? Anybody? Nice. Application program interface, says Harris. Okay. Very good. And an example, Haley? Anyone give an example? What about some sort of Android firmware? JavaScript. I'm looking for a more concrete example from your day-to-day life. The one that Zane mentioned, what about some sort of Android firmware? Let's start from there. So you develop an app for your Android device. What do you need to use to control the hardware, to make use of the hardware on that device? Maybe, yes. A software program, Tara says. Okay, all right, so good. I'm glad you're thinking. And Prakash, can you give an example?
Sure.
Relevant to our scenario here.
Yeah. So in the context of programming, what API is, we'll get to it towards the end of the session today. But before we get there, I would like to give an example of what API would translate to our daily life that we live. As an example, if you go to a restaurant, you go to the register and you pay, like you order food and pay for it, or maybe you know so what I wanted to say is, we don't have to know how the food was prepared, who prepared it, what resources went into it. What we do is we just go to one person, we pay for our food, we order our food, and we pick it up. So that becomes an interface, right? We go to bank to withdraw money. We go to this one counter and we ask for money and we get the money. We don't have to worry about where was the money stored, how did money come there, and all of those logistic at all. So this person we went to is an interface to the bank, right? That person represents function that a bank does, and it hides all of those details from us. makes life simple for us. So are the APIs, wherein things could be complex, and we don't have to know what the complexity is. We just want to use it. So API is an interface to using a functionality, um, and we look at a very specific few APIs towards the end of the session. So wait for that. Uh, Android firmware was a very good example of that, but it is very technical. Um, Now, what probably was meant by Android firmware is when we write an app, is, let's say, when someone touches on the screen of the phone, they don't have to know what happens when you touch a screen and what, like when you write the app, you don't have to know how that touch screen happened. You just get an event that, oh, user has touched the screen or user has pressed a button. So you don't have to know about what CPU architecture is underneath, what hardware it is, what is RAM and ROM. Those are very complex details. So API hides all of that from a programmer, makes life very simple. Am I clear about it? There's more confusion.
I understood. I'm also adding a thing a little bit here in the text box. API is a middleware. Okay, so for example, Java has a number of classes that you can invoke, you can call and use it without knowing a lot of details of who made it and how it is made. You just have a simplified version of the documentation that comes with that, and you get to use it and invoke those functions and utilize them for what you're trying to accomplish. So that's good. So it is a middleware.
Yes,
Yeah.
that's the right term for that. All right. So moving on, point number 4, Java is everywhere. And guys, remember when we started while in Java, we started from least important reason and to the most important. So now we are below 5, which means now these reasons are the most compelling ones to learn Java. So Java is everywhere. We touched this topic before in context of how 3 billion people use it and so on and so forth. But in this slide, what I want to capture attention to is in the right side of the screen is list of Fortune 100 companies. These are the wealthiest 100 companies in the world, and they all use Java. And I just couldn't fit 500 Fortune 500 companies in one slide, so I cut the list down. But Fortune 500 companies, they all use Java, and almost every company uses Java. This Google Hangout, somewhere, all this video, voice, chat, everything is going through some kind of a Java code base. Uh, and on the left of the screen is industrial sectors, all kinds of industrial sectors. So these are verticals, right? We had a question about what vertical is. So this is a good example of vertical. You can see there's airlines industry, there's oil, mining, healthcare, mobile phone, vehicles. So these are different verticals. Finance, they all, there's research and development, they all use Java. So being a good Java programmer, you can land up in any one of these kind of jobs, one of these companies, um, and you can easily switch. If you feel like exploring oil vertical, you can do that and come back to finance or some other sector you feel like. So it's very flexible. Point number 3, supports OOP. Now, this is going to be really interesting. Anyone guesses on what OOP is? Come on, can you read out once as you start getting the responses? It Harris, Rish, Edward, Ali, Nate, Parashar, Zain. What is OOP?
Did you say oop or oops?
Oops, oop, oop.
Yeah, I think they got it.
They got it. Everyone got it. Okay. OOP is object-oriented programming, right? So Java is Java supports OOP, and why is that a big deal? Why is that number three reason to learn Java? Uh, is because not all programming languages support OOP, and the reason why OOP is important is because as human, we interact with things as objects and not as tasks. Um, we don't operate television as a sequence of tasks. We just see television as one object. We interact with it through remote, which is again an object. So it's very common. It's a natural tendency of humans to interact with real life uh, elements as objects. So an OOP supporting language makes it seamless to get the concept of objects and how they interact with each other. Languages like C, those are functional languages. So as the programs go become more and more complex, it becomes more and more difficult to deal with those languages. OOP makes it easy. Uh, uh, so if it was, as an example, if it was C, then to operate a television, you would have to write everything, which is check the signal strength, check this, check that. Like there could be like gazillion of things that you have to write before TV can be started. But with OOP, you can just say TV power on, and it just starts working. Just an example. So what makes a language OOP a language? So OOP has four verticals. The language should support inheritance, abstraction, encapsulation, and polymorphism. This is not part of AP coursework, so I'll quickly go over it just to give you an idea of how powerful OOP is. Inheritance, as we all know, we all like kids inherit uh, genetic information from parents. Parents inherit from their parents, and so on and so forth. So, what inheritance is? Inheritance means getting some qualities as a gift from birth, right? So maybe eye color, skin tone, hair. We just get it from our parents and grandparents. Similarly, in programming, when we write programs, we don't want to write everything over and over again. We can just inherit some of those functionalities from some other class. So that's inheritance. Abstraction is when among friend we talk and we ask like, hey, what did you do over the weekend? And no one says I watched a game on a 65-inch Sony Vaio. That's too much of information. We just say, oh, I watched a game. Or no one says, I cooked something on a gas stove with wood. So there are too many details here, and very often then we realize is we as human we skip details. We just talk about things in general. We not always talk about our car's make and model every time we talk about our car. We just say I drove here in a car. We don't say I drove here in a 2005 Honda Civic or a XYZ. And that's too much of detail. So abstraction is a very common practice we follow in our day-to-day life, and Java also provides that kind of abstraction wherein anyone who uses your program need not have to know all the details about it. They just use API. Remember, we talked about API. They use a program as a middleware. Next is encapsulation. So it's very interesting and a very subtle and powerful feature of OOP. When we uh, drive a car, we don't we don't have to know about how engine is working, how fuel is being injected, how exhaust work, catalytic converter work. We don't have to know anything about it. What we have to know is how to use a steering wheel and gas pedal and brakes. Is that right? Isn't it that simple to drive a car? So encapsulation is to hide details from user. and just provide them very simple ways to control the object. So that is encapsulation is also something which we practice every day. So Java supports that. Polymorphism. Well, this is a good example here. Everyone speaks here, but everyone speaks their own way. That is polymorphism. Is poly is many and morph is shapes. So one what it means is you can have uh, uh, same piece of program which can behave in different ways depending on what context they're used in. So Java supports all of these verticals of OOP in really well. So it makes it easy to program in Java. Point number 2, portable and versatile. So Java is very portable and versatile. So on the right of the screen is versatility. As we touched upon it earlier, Java follows something called as Vora, is write once, run everywhere. We'll come to it later in the session today. How does that work? But the point here is you write Java code once, and you can run the same code everywhere where Java is supported without worrying about failures. Java is very secure, and this is to do with a couple of things. Security in context of cybersecurity. Java is very secure, is unlike C and C++ and few other programming languages which are vulnerable, which means they are exposed to exploits if the programmer is not careful. But Java inherently makes it secure. So even if programmer forgets to explicitly care about security, Java provides that out of the box. So Java programs are hard to hack. Security in context of correctness of program, Java compilers are very powerful. So and there's something called as type checking in Java, which is enforced, which means it will not let you use an incompatible object. So when you try to run a Java program, it won't compile. It will tell you this object is not compatible, and you have to fix it. You just can't go around it easy. So it makes it less likely to make mistakes when you write Java programs. So it makes it secure in terms of correctness of program. Java runs across networks. In all these websites, they run on some web server. They don't run local on our phone or computer. So if you have Java program running on some computer over the internet, you can run it from anywhere in the world. So that is very powerful about Java. Well, did I? Okay. So next is portable. To the left of the screen is what makes Java portable is it can run on Windows, Mac, Linux, or any operating system for that matter which supports Java. Let's say today we write some program, and some of us will be running the same program on Mac. Some will be running on Windows. Who knows? Someone is running on Linux, and we'll see we get the same output everywhere. Um, so that's very powerful, and we don't have to do anything different for running them on different operating systems. Point number 1, the most important, is popular and high salary. This graph, it's too complicated because so many lines here. But the point here is line in blue is Java, and it is above all other lines which are different programming languages put on a graph. So an average pay package for a Java developer is somewhere between $75,000 to $150,000. So Java is very popular. There's a high demand for Java everywhere, and people who know Java are compensated really well. So that's definitely a big motivation to learn Java. As an example, why to learn, let's say, PHP and like why to learn only PHP and maybe get less pay? Why not learn Java and get higher paid, and then you can also learn PHP? There's no limit on learning. What I'm saying is, if the one programming language you want to learn should be Java, is because definitely it'll fetch you job sooner and a handsome paying job. So before we go to the next section, which is what is Java, any questions that I can answer?
What is the difference between Java and JavaScript?
That's a great question. When I started working on JavaScript, I had the same question. I thought both are same, but they're actually not same. So Java is a programming language, whereas JavaScript, by the name of it, is a scripting language, and it has nothing to do with Java. JavaScript is so. What is a scripting language? A scripting language is something which is not compiled; it is interpreted. So JavaScript is not compiled. When you run it, it is interpreted. Whereas Java is programming language; it must be compiled before you run it. So these are few differences between the two. But going back to the history of JavaScript, Java started gaining popularity, and everyone started talking about Java. And earlier, in before the dot-com bubble in 2098, I guess, websites used to be very dumb, which means they would just have static content. You go to a website, it'll just download a bunch of text on the screen with some formatting, but that was it. But now, if you go to a website, it is interactive. There's Flash Player. There's some animation. There's so many things on a website happening, and that is all because of JavaScript. So there was a need for some kind of a programming construct that can run on in a browser, right? So the developers of JavaScript, they wanted to make something very simple for for anyone to use. And as Java was gaining popularity, this is my belief. I could be wrong, but the name JavaScript kind of just uh, just riding over the popularity of Java itself. So JavaScript is a scripting language. At the end of it, Java is a programming language. That's one of the major differences between the two. JavaScript doesn't have OOP. Well, now you can kind of modern JavaScript frameworks do allow the OOP concepts to be added, but originally OOP was, I think, still even now is not part of JavaScript. It is more a functional language, whereas Java is a OOP supported language. Did I answer your question?
Yes, thank you.
Zane is asking a question: is the compiler built into Java or is it based on the IDE? So the JRE, Java Runtime Environment, is a virtual machine that has the compiler, and Prakash will go over that. And again, you will run some test program today.
Correct. So there's something called a JRE, Java Runtime Environment, as Kumar mentioned. So you need JRE to run a program. Um, but so and then JRE does not have a compiler is because just with JRE, or maybe it has. Let me take it back. So just with JRE, you cannot write and run a Java program. You need to have a JDK development toolkit for Java, which has definitions of all the classes. And I think compiler is part of JDK. So you need the JRE to run Java, whereas you need JDK to write Java programs. And we look at that towards the end of the session. Any more question?
Are we going to be using databases from online to program?
As part of the AP coursework, we will not be using databases. We'll be focusing on Java itself, but using like when we do things the right way, we'll see that using database online or offline or from a file, they all become seamlessly simple. So if time permits, and if you all are interested in it, we could run like a simple program or something which uses database.
Okay.
All right. Any more questions before we move on? Well, I'll take it as no. So I believe we got convinced why to learn programming and why to learn Java as a programming language. Now we'll see what is Java. We're talking about it so much. So in a very simple, simplistic example here, there's one English-speaking individual. He can speak only English. There's another person who can speak only Spanish, and they want to talk to each other, but they cannot, is because they don't understand each other. So what they need to talk to each other is a translator, someone who can translate English to Spanish and maybe vice versa. So Java is a programming language, as we have been talking about it, and if you look at Java, it is similar to example that we just looked at. It's a language wherein a software developer writes program in English type language, which they can understand. But there's a computer that can understand only binary, which is sequences of zeros and ones, which is impossible for a programmer to write logic in zeros and ones. It's too complex. So what a programmer does is they write everything in English type language. A compiler comes into picture. It converts the program into sequence of zeros and ones, and then now that can be understood by the computer, and computer runs it. So that's what Java is convert ideas, logic, everything into something that computer can work with. In a very generic overview, and as we progress in the course, we'll realize Java is, well, any programming language for that matter, is essentially manipulation of data, and the programming is all the logic around it. So at the end, it is manipulation of data. Either you store it, you convert it from one form to another, display it, take input from user, give output to user. It's some kind of data, and all the program we write is just to transform the data the way we want it. All right, so we'll run hello world on a in our IDE today. And before we do that, let's go over some insight on how that is going to work. So as we looked in the previous slide, a programmer writes a program in English type language. And in this example, the first box there, left top corner, is a hello world.java file. It is a standard convention for a Java program, for Java file to end with .java. So we write our program there. In Java, everything is inside of a class. So there's a hello world class there. Once we have written this program, we save it and we run the Java compiler. We ask the compiler to convert the Java program we wrote into something that machine can understand. So we run a command called javac and pass it the file name. So the compiler compiles the whole program into something called as bytecode and saves it into a file generally ending with .class. So we'll see how java world.java will result in another file called java, like hello world.class. Now when we run this hello world.class, that's what we run. It invokes Java Virtual Machine, JVM. Java Virtual Machine takes that bytecode, converts it into a machine code, which is actual zeros and ones, using something called a just-in-time compiler, and then run it on the computer, and we'll see the output on our consoles. So this is a very high-level view of how a Java program gets translated into an output. Right? Any questions here? I'll take it as no. Okay, go ahead. Sorry.
This question is for the students. So you heard byte code and then machine code. Share your, give an example. Explain this. Not this is for the students again.
Okay.
Anybody? What is the machine code? Anybody? I mean, you're still looking at the screen. Nice. Okay. Machine code is binary. And then the byte code? You need to see the layers from your keyboard. You're programming it and you're writing it in that language using the specific way of defining the different words, the terms, say punctuation marks in this case, indentation, and then what happens to it when you try to run that. Okay, I think the programming language is Java, Parashar. Is there a difference between, he has that on the screen. See the layers. Like look at as a column. The first column, the second column, and then the third. This is very important, even for troubleshooting. When you are running the code, sometimes it'll throw an error. If you have a good understanding of this, it's going to help you troubleshoot that. Okay. Anyways, keep thinking about this, and Prakash, go ahead.
Sure, but then it's a great question. What is bytecode and what is machine code? In fact, the reason why because there is a bytecode, that's what makes Java to run everywhere. What from a very high level point of view, you guys can research about it in more details, but it's not part of AP coursework. So we'll just go over it real quick so that we know what is bytecode. So what Java C does is a Java compiler, which is it converts a program into an intermediate language that Java virtual machine can understand. Now, wherever a Java virtual machine runs, you can take that bytecode and run it on that JVM, and most likely it'll just run fine. So why does Java C not compile the program into a machine code directly? Why go through JVM? Is because it's not that simple. Machine code is not platform independent. Like as an example, phones generally use a CPU architecture called ARM, advanced something. I'm forgetting the acronym, but they use ARM processors. Some computers have 32-bit CPUs. Some have 64-bit CPUs. Some are AMD. Some of them are Intel. So there are different CPU architectures and so on and so forth. So each machine is going to have a different machine code. So when you compile a program into machine code, what machine code are you going to compile it in? That's unknown. You want to run it on all kinds of machine. So what Java C does is it converts it into a intermediate bytecode, and when a JVM runs on each machine, the JVM understands what kind of machine code that specific computer knows, and it converts the bytecode into the machine code that individual computer understands at the runtime, like just-in-time compiler. So because of this, it makes Java programs portable. You don't have to worry about what computer architecture is wherever the program is going to run. Does it help? Hopefully it helps. All right. So you know what? We have been talking about so many things. It's time to write a program. How about that? Right, and then we'll come back to our review. So everyone, open your IntelliJ. But before we do that, any questions?
Okay, at this point, we need to be working together. All of you kind of be in the same phase of doing this so that everybody gets this thing done. And let's make sure that you are able to start IntelliJ. And if you are not able to run it, open it, or you're having some issues, let us know.
So once everyone is ready, we should be seeing something that is on my screen. Welcome to IntelliJ.
Let us know where you are if you have open IntelliJ.
Yeah, feel free to unmute and speak up if there's any problem. Okay.
Harris, you're right. Yes, it converts into a form where every OS can understand and process that code. And it understands at the binary level. All right, looks like we're ready to move.
Okay. So what we do here is we'll create a new project. So everyone click on create new project. Make sure on the left Java is selected. We don't have to uncheck anything. Just click on next, which is right bottom of the screen. We do nothing on this screen here. We just straight away go next. And when you come to this screen where it says project name and project location, for me, what I've done is on my desktop, I have created a.
I have a question.
Yes.
I tried going in, but it says no SDK is specified, and then it asked me if I want to create a project with no SDK assigned. Should I just hit yes?
So go back to first screen, and from this drop down, you don't have anything specified there. Do you see any SDK at all?
No.
Okay. Can I look at your screen?
Yeah. All right. I'll share.
Wait, so do I just use the one that says 14.0.1?
Yeah.
Okay.
Yeah. Yeah. For me, I'm using 13.01, but that's fine.
All right. This is what it looks like. So.
Okay. So time to download the JDK. 14.1, right? Yeah. Let it download.
All right. Thank you.
Yeah, no problem. So what it is doing is it didn't find the JDK, and it just it'll download it for you. It may also be possible that am I sharing my screen? Let me share it. Okay.
Do we just call it Hello World?
Come again?
Do we just call the program Hello World?
Yeah, I think let's call the first program as Hello World. Hello World has become a common theme across all the programming languages. First thing we learn typically it is Hello World.
How about Hello Corona?
How about Hello Java? You can name it anything. It's we'll in the next session on Java, we'll touch on this topic of how things should be named in Java. There's a standard convention that everyone follows. Typically, these conventions they fall under coding standards. So you can write code in different ways, but the reality of writing code is generally the program is written once and it is read multiple times. What we have in the chat window here is, should we check create project from template? No, do not check that. So while we wait for the JDK to be downloaded, for everyone else, you can go to next and then do not check any of that. Go to next, and the project name you can pick your own name, hello world or whatever, and then pick a project location. For me, what I've done is on my desktop, I have created a AP CompSci folder, and in there, I would create a folder like hello world and use that. So the moment you do that, it automatically picks up the folder name as a project name, and then you can hit finish. While you can hit finish and explore the IDE, I'll wait here for everyone to have JDK.
I've got a question here from Zane and Nate.
Okay.
So you still have the same issue? It says JDK is not assigned. Did you overcome that? Oh, no more of that is a problem. You fixed it.
Okay.
Got it. Okay, good. Very good.
Awesome. So anyone else having that problem still? Because now I think everyone, we all have JDK in our IDE. Mine is still downloading. Okay. I'll wait for you, Rish. Everyone else, you guys can hit on next and create a project. Okay, no problem. I'll wait.
We would like everybody to be on board with this and be able to do this. Don't try to do this on a paper. Make sure that you're doing it on your computer.
Yeah.
And it's, if you run into a problem, that is good news, because only by making some mistakes you will learn better.
That's absolutely true. Yeah. All right, Rish, you're good?
Yeah, I'm good.
Okay, so let's all start now. Java, hit next. Do not check the template. Give your project a name. Make sure that it is getting stored at some location you can access. In my case, I'm doing it on desktop. And hit finish. The IDE should load, and you should see something similar here. Anyone seeing anything different? Make sure on the left, do you see this drop down? You have project. That's a view of your project. All right, I hope everyone is here. If not, feel free to stop me and then we can look at the issue. Now, if you expand the hello world directory, you'll see there's a folder named src. So mostly all Java programs, they end up in a folder named src, which is source code essentially. Here we'll first create, it's just a hello world program for us. We'll not go in big details, but technically we should have made a package first. But we'll do it in later sessions. For today, we'll create a Java class file. So the way you do that is on source, you do a right click, go to new, and then Java class, and give it a name. Let's give it a name, hello world, and hit
For some
enter.
reason, mine's not working, or it's not showing up that way.
Yeah, same with mine actually. I don't have the .idea folder or anything.
The .idea folder. That's
Yeah,
fine.
I only have the
I
thing
don't
that
have-
says project.
And my project at all, actually. Like, I
Can
don't
I-
have hello world there. Like, really weird.
Can I look at your screen?
Yeah. Do you want to go first or should I? Doesn't matter.
Hallie, go first, and then we'll come to your, because I think your problem is simpler.
Okay.
Hallie, do you want to share your screen?
I don't know how to share my screen.
If you hover your mouse towards the bottom of your browser window, to the left corner, you should probably see something like share your screen. Let me see if I can explicitly. Kumar,
I
is
don't
there a
think
way
you
to?
share it because you're sharing.
Yeah, I can maybe make you the presenter. Maybe not. Let me stop
No,
sharing.
you can do that yourself. Yeah. Okay. So now let's try it. On your screen, if you double click, it'll become full screen mode, and then at the bottom right corner, you should be able to see those specific buttons.
Yeah, you should see present now at the bottom of the screen.
Yeah. And
Are
then
you able to?
share your entire screen, and it's not letting me share it.
Okay. So when you open the IDE, what do you see on your in the left column?
When I
You
open
see
the what?
the IntelliJ. So
When I
what do you
open
see?
IntelliJ on my left column, I just see external libraries and scratches and consoles.
You don't see Hello World?
No.
Okay.
Let's try again to share the screen.
For some reason, it says it's like asking me if I want to share my entire screen, and then
Yeah.
I click on the
Yeah.
share button, like it. Yeah.
Oh, because you click on that screen. So when it asks you, yeah, click on that, and then the button gets activated.
I'm clicking on that screen.
Just click once, and then the button doesn't get activated.
No.
So when you click on present now, it should give you two options, your entire screen and a window. So when you click on your entire screen, then it pops up something. And then in that pop-up, you select that one screen, and then share should get activated. You're using Chrome, right? Okay. How else can we?
Is there any way I can like create a new project?
Yes,
Okay.
you can close the IDE. So let me. Okay, so hold on to that, because then I'll share my screen and then we can create it again from scratch, right?
Okay.
How about how about Harry? Harris, did you have the same problem? Did you have some problem with the ID as well, right? Was it you?
No, that wasn't me.
Yeah, I had. I mean, for my. Should I share my screen?
Yeah.
Okay.
So Ali, we'll get back to your problem and we'll create the whole thing all over. I think it'll solve the problem then.
Yeah, am I sharing right now?
Yes.
Okay, so mine just looks like this. Is it okay, right? Or is there something wrong?
Click on that project. Click on package. No, okay, hold on. Stay there. Okay, settings. So click on, okay, let me see your screen again. You see that setting icon, right? On there's like a gear icon on the left column. No, up where the project is, where the project drop down is.
Oh yeah, sorry.
To the right is. Okay. Do you know where you have created this new project on your computer?
Yeah, I just put it in. So I have this file, whatever you said, and then when I opened this, it's all this stuff.
When will class be over?
8:30.
Okay.
Okay, so I can see that. So your project is there for sure. You can see the source folder, right? But what we are not able to see is in the IntelliJ, it's not visible. So I think what might be going on is, give me just a second and I'll try to see what's going on. I'm trying to reproduce the same problem on my computer. Modules.
So it looks like we need to go to
Okay.
Haley that's having the problem.
Yeah. So quickly, Parshar, can you do one thing?
Yeah.
Go to File and wait a minute. So go to Project Structure. By the way, Hallie, are you having the same problem as Parshar is having, or do you have a different?
No, I had a different problem, but I created a new project.
Okay, that's great. And now is it solved, or do you?
Yeah,
See? Oh, perfect.
Oh, nice.
Great. So Parshar, can you go
We're
to
going to
File?
drive to your place and fix it.
And then click on Project Structure, one above, and click on Modules. And then click on the plus sign there. Is the name of your project Untitled?
Yeah, I haven't.
Okay.
Yeah, I can just try to change it. Oh,
There's no space, I guess. It won't let you. So in there, why does it not pick up? Can you try making a project again, like a new one?
yeah. I don't select anything here, right?
Don't select anything. Next, don't select
Nothing.
anything here. No. And then name something. Hello world. Yeah. Go finish. Do a new window. There it is. I think maybe
Yeah,
the
that
untitled
works.
default. Yeah. So you can close this the previous IntelliJ if you want. It's better to close it.
Yeah, sure. Can I delete this or?
Yeah, you can delete it. Well, there's no way to delete it from the IDE.
Okay.
Yeah. All right. Okay. So now we all are on the same page, I guess, right?
Mm-hmm.
No, I'll recommend not to do that now. Okay. All right. So I'll take the presentation back from Prashar. That's okay?
Yeah.
Okay. So entire screen, share now. All right, everyone. So now we all know how to use IntelliJ. So let's all come back to where we were. I'll so everyone on the source folder, do a right click, new Java class, give it a name. Hello world is a good name. And once you do that, you'll see IntelliJ opens a file for you. It creates a file called hello world.java for you.
Source is src, right?
Correct.
Okay.
Do we all see this? All right. So once we are here, we'll just write what I'm typing on the computer screen here. We'll get into details of it as the module, like as we progress in the course. But as of now, we'll just write a few things. We'll take it as is, and we'll run the program. So everyone write system system.out dot println and write hello world. Right. So that's one simple program right there. Well, that will not work actually. Take it back. Just go to the beginning of the line and put 2 forward slashes. That comments it out. So we'll come back to it. But what we need to do first is we need to have a main method. So in a lot of programming languages, when you run a program, there has to be a starting point where the program should run. Now we need to specify where the starting point is. So first we'll specify where should our program start from, and that is done by something. Just follow what I'm writing. Is public static void main string. So what we're doing here is we are saying in Java the starting point is main of a main function or main method. So what we're saying is for our program, this is the main method that we want Java program to start running from, and this method returns nothing, so it's void and it's static, so we don't need to create an object for the class to use it. We'll get into more details of it. Public means anyone can call this method without and then static means you don't need to create an object of it, so you can call the method without creating an object. Now once we have written this function, we go and cut that piece of line that we earlier wrote and we paste it here. So now what we're saying the program is start my program from this function and then on the output of the system, print hello world. Right. So once we are done here, you can go to run. Click on run, and here you will see there's a hello world configuration. Just click on that hello world and wait for the magic, and then you can see hello world being printed here. So did we all see this happening?
For some reason, I can't write anything down. How do you get to the writing thing?
Okay. Can you share your screen? Okay, so on the SRC folder, do a right click, new, and then the Java class, right? Click on that, and then write hello world. One word, yeah. Just hit enter. There it is,
okay.
right? And then between those two curly brackets, you can start writing the code.
Okay.
Okay.
That's it, right? Yeah. Okay.
Yeah. So I'll present my screen again. So hopefully everyone.
How do you get it to print?
How do I get it to print? So this API, it prints whatever you give it onto the screen. So once we all have written this, then go to run menu on the top, and then there's this run option. Do you see that?
Yeah.
And then you click on that, and it'll probably give you a few options. So click on the hello world option, and then when you click on that, it'll do the magic, and it'll.
It didn't give me a hello world thing.
It did not print anything?
It just says run and then 0 with a pencil saying edit configurations.
Can you share your screen?
Okay.
Yeah, mine also just says run configuration, and I don't see hello world.
Okay, so when you click on run, there's this. Okay, you don't see. Okay, maybe it's a different.
For some reason, for me, the run is grayed out. Like I can't click it and I can't run at all.
Got it.
Then you press Alt Shift F10.
So I go here and it's just.
Okay, do edit configuration. I think it is some Windows thing. Okay. Let me replicate it on my computer. So do you have? So click on the plus sign there, right above the template.
Okay.
And then application. And then the main class is hello world. And give it a name, hello world. And the main class is hello world 2.
Why is it red?
Yeah, because on the top there's a name option, name that to hello world. And
so in main class, I just put hello world, right?
Correct. Yeah.
It
Just
says
hello world.
default package and sun.jvm.hotspot. Which one?
And then just
Okay, we'll get to it. Working directory, is that the working directory, right? The D drive Java program bytes and bots. Okay, so no space in the name. Yeah, even on the top, like, okay. So looks like now you have main method not found. Do apply. Go back to your program, close it. You do have main public static void. Okay, now go to run and see it picks up. Run hello world, click on that, the first one. Yeah, there you go. Click hello world.
Okay.
Print, that's not IN, it's LN.
Oh,
Yeah, now save it and do the same. So what's the bad configuration? So your configuration name, you have a space in the name of it. So click on run. Go to the run. Yeah, go to run. Click on that, and then go one level up. The configuration thing. Yeah, click on that, and then see the name you have has a space in there.
oh,
Remove that space. Apply and run. Do a run from here. See if that works. So you have an error at the bottom of the screen.
it's saying error running hello 14 is bad configured.
14 is bad configured. What is 14? That's so bizarre. Um, How about everyone else? How many of you are having problems?
I am.
Okay, same.
Yeah, I can't run it either. It's not showing the hello world thing. I
Okay.
think.
Yeah, me too.
So, okay. So you all had similar problem as Harris, right?
Yeah, I'm trying to make the configuration to run it.
Yeah. So Harris, let's go back to the configuration thing, which is you click on run and then you click on that alt control run thing, and then open the edit configuration option. Okay, so your working directory is right, correct? So your program is saved in D drive, Java programs, bytes and bots, hello world, correct? That's the right location.
Yeah.
So what is different? Okay, so can you click on the directory icon next to working directory on the right? There's this directory. Click on that.
This one?
Yeah. Expand the hello world.
Okay.
Okay. Okay. Expand out. Expand hello world. Okay.
Click OK.
I think no, cancel it. I'm just checking if your directory structure is right or not. So it looks like there's some IDE configuration issue, but in the interest of the time, let me take the screen presentation and then let's finish what we were doing, and then we can keep exploring on case by case basis and fix this problem, right? Because not everyone is stuck, so let's free everyone else, and then we can come back to solve this problem.
Okay.
And we'll I'll stop your screen sharing, and real quick, what we'll do is we'll So you, one really doesn't really require IDE to at least write a hello world program, and I'll quickly demonstrate that as well, just in case your IDEs are not working. You can still do this exercise. Create a new folder, name it something. I'll just say command line hello world, and then in that folder, just create a file here. So let me create a file. So create a file, and then you just write public class. Whatever you wrote in the IDE, you can straight away copy paste it. It doesn't have to be. So in the IDE, this whole thing can be copied. It can be pasted into just a text file, and then you can save it. So I'm saving it on my download the desktop, on my desktop, computer science. Here, I just name it as hello world.java. Then you can open the command line and you can go to then when we see there's a Java file here, we can do a Java C. World. So what we're doing is we're compiling the Java file, and if we look at what after compiling happens is, you see this hello world.class file. Remember in the presentation we were talking about binary, like a bytecode intermediate file, it gets generated. So after compilation, that's what gets generated. So you can open the hello world file and you see it's English, but if you open the class file, you know what, it'll run the program. So you open it into a notepad as an example, you'll see it's some garbage information. So it's something that we can't understand, but JVM definitely understands. So that's what the Java class file is. And if we need to run that, we just do a Java hello world, and it prints hello world right there. This is a very simple Java program. The idea here is we really don't need an IDE for AP course to progress, but it's good to have IDE functioning. It makes it easier. And I think that concludes our today's session. What did we learn today? We learned about why to learn programming in 5 simple ways, why Java in 10 simple ways. What is Java? Programming language to interact with the computer. And we wrote hello world program. What we did is we printed to the console. We did not receive input from the user. But in the interest of time, we can cover that later on in the next session. But the idea here is, so far what we did is we write hello world here, we print hello world, but we have not taken any input from the user yet. So if user wants to put a name, and your program should output hello, let's say Nate or Zane or Rish or Harris. So you can take input from user as well. We'll cover that in the next session. So that's the end of the session from my side. If you have any question, please feel free to ask. And
when you're planning to run it, and it says run hello, I mean, what does it say for you? For me, it says, I don't know. I just kept clicking through, and it says hello world, $sign and main. Is that what it's supposed to say?
So when I click on run, you can see my screen, right?
Yeah.
When I click on run, I have 2 options: edit configuration and hello world.
Okay.
And then I just click on hello world, and it works for me.
Yeah, I have that too. Okay. Okay, it works.
It works, right?
Mhm.
So it looks like some of the window machines have some configuration off in them because this is supposed to be default. So we can look at how about this? We can end the session today, and when the next session starts, um, I'll have a solution for what the problem is. It must be some simple configuration issue somewhere. All right.
All right.
Thank you.
Okay, thanks everybody. And one real quick thing, make any questions, save those questions for the next class. And also, like earlier, Prakash mentioned, what is that called? Stack Flow?
Stack Overflow.
Stack Overflow, and other sources are there. You can actually go Google, find out some of these errors or the symptoms and try to solve it yourself, which is also part of the learning process. All right. Thank you, Prakash.
Thank you, everyone. I'll stop the recording.